Okay, we're on week 13 and still talking about wave properties. Today, we want to talk about wave speed. So we hope that by the end of this lesson, you'll be able to explain wave speed in a variety of different ways. Assume that you move one end of a rope up and down just once to generate a wave in the rope. How long will it take the wave to travel down the rope to the other end? It depends on the speed of the wave, doesn't it? Wave speed is the distance a wave travels in a given amount of time, such as the number of meters it travels per second. Wave speed and speed in general can be represented by the equation speed equals distance divided by time. Wave speed is related to both wavelength and wave frequency. Wavelength is the distance between two corresponding points on adjacent waves. Wave frequency is the number of waves that pass a fixed point in a given amount of time. This equation shows how these three factors are related. Speed equals wavelength times frequency. We can also look at it as velocity equals frequency, f, times wavelength, lambda. In this equation, wavelength is measured in meters and frequency is measured in hertz, or the number of waves per second. Therefore, wave speed is given in meters per second, which is the SI unit for speed. Question: if you increase the wavelength of a wave, does the speed of the wave increase as well? If you increase the wavelength of a wave, does the speed of the wave increase as well? The easiest way to figure this out would be to put numbers in with it and figure out if the speed increases. Take a moment and pause the video. See if you can figure out. If we increase the the wavelength of a wave, does the speed of the wave increase as well? Oh, trick question. Increasing the wavelength of a wave does not change its speed. That's because when a wavelength increases, wave frequency decreases. And as a result, the product of wavelength and wave frequency is the same speed. Gotcha. The equation for wave speed can be used to calculate the speed of a wave when both wavelength and wave frequency are known. Consider an ocean wave with a wavelength of 3 meters and a frequency of 1 hertz. That means the distance between crests of these waves are 3 meters, and the frequency, how often they go past, are 1 hertz. Therefore, to find the speed of the wave, we just simply plug in this information. For frequency, we plug in 3 meters times the wavelength, which is 1 wave per second. 3 times 1 is, okay, all you mathematicians, go for it. You're right, 3 meters per second. So, Kim made a wave in a spring by pushing and pulling on one end. The wavelength is 0.1 meters and the wave frequency is 2 hertz. What is the speed of the wave? Take a moment, write down the equation, exchange the information you know for parts of the equation, and figure out the speed of this wave. Pause the video for a moment. You're back already? Awesome. So we substitute the values into the equation for speed. Speed equals 0.1 meters times 2 waves per second. That gives us a speed of 0.2 meters per second. How'd you do? Great. Okay. The equation for wave speed, speed equals frequency times length, can be rewritten. We can find frequency by taking speed and dividing it by wavelength. Or wavelength, we can find by taking speed and dividing frequency. Therefore, you know the speed of a wave, and if you know the speed of a wave and either the wavelength or the wave frequency, you can calculate the missing value. Let's say you know the speed. The speed of this wave is 2 meters per second, and it has a wavelength of 1 meter. So here's our formula for finding frequency. Frequency equals speed divided by wavelength. Plug in the various variables. Speed equals 2 meters per second divided by 1 meter. And we get a frequency of 2 hertz. Now, the medium actually does matter. It makes a big difference what medium we're using. Liquid, gas, or solids. They travel faster through solids. In summary, wave speed is the distance a wave travels in a given amount of time, such as the number of meters it travels per second. Wave speed is related to the wavelength and the wave frequency by the equation speed equals wavelength times frequency. This equation can be used to calculate wave speed when wavelength and frequency are known. The equation for wave speed can be written to solve for wavelength or frequency if the speed and other value are known. The speed of most waves depends on the medium or the matter through which they are traveling. Generally, waves travel fastest through solids and slowest through gas. Do you understand wave speed? If so, you may move on to the next activity. If not, please go back to the video and review it one more time. Thank you for being here. You guys are great. See you again soon. Bye.